Increase or decrease in time period. Increase or decrease in time period of a pendulum clock. Time period of a pendulum clock for a change of temperature, for a change in temperature by delta T Kelvin, change in temperature by delta T Kelvin or delta T degree C. Delta T degree C. Increase or decrease in time of a pendulum clock for a change in temperature by delta T Kelvin. In the diagram, a pendulum clock is shown. In the diagram, a pendulum clock is shown. Here, L is the effective length of the pendulum clock. L is the effective length of the pendulum clock. At the initial temperature, theta 1 equal theta degree C. Here theta 1 is the initial temperature which is equal to theta degree C. That is the initial temperature of the pendulum clock. Theta 1 equal to theta degree C, which is the initial temperature of the pendulum clock, which oscillates with an initial time period T. This is the pendulum clock. This is the pendulum clock. T is the time period, initial time period of the pendulum clock at the initial temperature theta degree C. Now the temperature of the pendulum clock is increased. Now the temperature of the pendulum clock is increased, and due to rise in temperature, effective length of the simple pendulum increases to L plus delta L. Final length of the pendulum becomes L plus delta L at the final temperature theta 2 equal theta plus delta theta degree C. Final temperature is theta 2, which is theta plus delta 3 degree C, and time period becomes T prime, which is T plus delta T. T plus delta T. Time period of the simple pendulum or pendulum clock increases to T plus delta T, increases to T plus delta T. As theta 2 greater than theta 1, as the final temperature theta 2 is greater than the initial temperature theta 1, that's why length of the pendulum increases. That's why L plus delta L is greater than L. Here temperature of the pendulum clock is increased. That's why length of the pendulum clock also increases. Length of the pendulum clock also increases. That means length of the pendulum clock is increased. Now time period also increases. That's why T prime is greater than T. Here time period of the simple pendulum increases because time period is directly proportional to square root of effective length of the pendulum. In this case time period increases. That's why frequency, as time period increases due to rise in temperature, that's why frequency under bracket nu decreases because frequency is reciprocal of time period. And the pendulum clock runs slow. That means the pendulum clock loses time. The time period of oscillation of the pendulum clock at the initial temperature theta 1 is equal theta degree C. Time period of oscillation of the pendulum clock at the temperature theta 1 equal theta degree C is given by T, which is equal to 2 pi root over L by G. T which is equal to 2 pi root over L by, where L is the initial length of the pendulum clock at the initial temperature theta 1 equal theta degree C. L is the length of the pendulum clock on at the temperature theta degree C. Therefore, T can be written as 2 pi L to the power half G to the power minus half. T is as equal to 2 pi L to the power half G to the power minus half. Therefore, delta T by T is equal to half delta L by L plus delta G by G plus half delta G by G. Delta T by T is equal to half delta L by L plus half delta G by G. That is the relative error in the measurement of time period of the pendulum clock due to change in temperature. Relative error in the measurement of time period of the pendulum, or comma delta T by T is equal to half 1 by 2 delta L by L, where delta G is equal 0 as the acceleration due to gravity under bracket small g is constant. That's why delta G is equal 0 is constant, or is assumed as constant. Delta T by T, which is equal to half delta L by L, which is equation 1. Again, the coefficient of linear expansion. Again, the coefficient of linear expansion of the string of the pendulum clock is alpha, which is change in length, that is delta L divided by L into delta theta. Alpha is equal to delta L divided by L into delta theta, or comma delta L, which is equal to L alpha delta theta, which is equation 2. Delta L is equal to L alpha delta theta, which is change in length, where delta L is the change in length of the pendulum clock. Delta L is the change in length of the pendulum clock, or change in length of the string of the pendulum due to change in temperature by delta theta degree C or delta theta Kelvin, by delta theta degree C, that is by the temperature delta theta Kelvin. Using equation 2 in equation 1, we get delta T by T, which is equal half delta L by L. Now putting the expression of delta L, we get 1 by 2. We get delta T by T as equal half, putting the expression of delta L, that is L alpha delta theta by L. Therefore, delta T by T is equal to half alpha delta theta, or comma delta T equal half alpha delta theta into capital T. Delta T, which is equal to half alpha delta theta T, which is the increase of time period, increase in time period of the pendulum clock. Increase in time period of pendulum clock due to rise in temperature due to delta theta increase in temperature of the pendulum clock. Delta T is equal to half alpha delta theta T. Total time in second in a single day for a pendulum clock is given by delta T, which is equal to 24 hours, equal to 86,400 second, 86400 second. T is equal to 86400 second, which is the total time in second in a single day. Therefore, in one day delta t is equal to half alpha delta theta into capital T, which is equal to half alpha delta theta 86400. So we get the amount of absolute error in the measurement of time in a single day, which is equal to delta t, which is equal to half alpha delta theta 86400. Delta t is the increase in time period of the pendulum clock. Delta t is equal to half alpha delta theta into 86400, which is the increase in time period of pendulum clock in one day. In one day, due to delta theta degree C increase in temperature, As the time period of the pendulum clock increases, the frequency, its frequency under bracket nu equal 1 by capital T decreases, frequency decreases. Hence the pendulum oscillates slowly as compared to the normal temperature. The pendulum oscillates slowly as at the higher temperature. The pendulum oscillates slowly at the higher temperature, theta 2 equal theta plus delta theta, and the pendulum clock loses time by delta t, which is equal to half alpha delta theta into 86400 seconds in a single day. Seconds due to increase in temperature by delta theta degree C, due to increase in temperature by delta theta degree C or delta theta Kelvin. Hence the pendulum clock loses time by delta t seconds due to increase in temperature by delta theta degree C.